-4 and 4. Then we're going to build up our attribute, and the way we access the each vertex is with the name of the helix, and then the attribute is VTX, and they let you use these brackets almost like you're indexing an array, just like this, to get each vertex in the list. And there's 20,000 of them, so every time we loop, it's going to be 0, 1, 2, 3, and that's going to be the attribute name. And then we're going to use the move command to move it by our random amount. There's the attribute name, and we're just going to move it in the x-axis. So this is going to happen about 20,000 times, and then at the end, we're going to delete the helix, clean it up, catch the end time, and return the difference of how long it took to run the test. Okay, so let's move down and let's look at what it takes to do the same thing using the API, which is now new to us. I'm going to scroll down, and you're going to see that there's more code in here, and that's something that you have to get used to with the API. Is it takes more lines of code to accomplish similar things. So we still create the start time. We still create the helix the same way because this is already given to us. Oh, my mistake here. This was copied from another module. There we go. Let's make sure we're calling the commands module. And so we get the helix, and the same way, because this is actually a wrapper around the API, and it's already given to us for free, so there's no reason for us to try to recreate a helix. We want to keep everything the same. And then here's the part where it starts becoming different. In order to get the string name into a node, which the API requires, we have to create this selection list, which is kind of like an array, but it's how you deal with things that are currently selected. And then we create this empty M object. And this M object is a special object in the API where it's your handle to everything, all the objects in Maya, because Maya owns all the objects, and you create these M objects to refer to them because you don't actually own them, Maya does. So anytime you want to store a reference to an object, you have to create this M object. So we've got these two items here. We take the selection list and we add the string name of the helix to the selection list, and then the selection list has a function called getTheDepend node, and we want there's only one item in the list, so we want the first item of the list, and to store it in node. Now this syntax looks different than what we've been doing, and this is more C++ like. As opposed to it being node equals, much of the C++ likes to store it in the last value. So you would say I want the depend node of the number 0 index of that list and store it in this node. And you have to pre-create the node because you're saying turn this node into the depend node. And that's much different. You have to create things ahead of time in this API. Then we go down here and we're going to create a vector using mVector. And a vector is just going to be our point because we need to supply x, y, z, and this is how we can store x, y, z. Now the next thing you have to do is to loop over every vertex in the mesh. We have this iterator, and this is where the API excels because it gets faster. You're doing this C++ style as opposed to a for loop in Maya and pulling out all the names of each vertex. So we've got this iterator, and this is anything that starts with MIT is an iterator, a special way for us to loop over whatever it says, mesh vertex in this case. So we create our iterator off the node that has the name of the helix, and we get back this iterator object. And the way you use it is you say, while it's not done, because this is pointing already at the first item, the first vertex in the iterator. And the way we increase that is by calling next. Every time we call next, we get the next. This becomes the next item in the iterator. So we just say a while loop. While not this iterator is done, so as long as this iterator is not at the end, we're going to create a vector. We created the vector once, and we're just going to set the x position to a random point. And then we're going to use iter translate by that vector. So every time this loops, it's going to get a new random x and translate that specific vertex by this amount. Then when we call next, this iteration advances one spot to the next vertex. So this is going to loop until there's no more vertexes. And finally we call delete node, which is similar to commands delete, but we're using this mglobal, which is a lot of utility functions that you can call, and you just pass it the node. It looks very similar to commands delete. You can just pretend that there's the global in there and it's almost the same. And then we just close off our time and return it. So you can see that's a lot more code to get from here to here, and it's a little bit new and obscure, and that's why we consider this point starting to border on the advanced level, because this requires you to start thinking in terms of C++. Now let's look at PyMel. Let's go down here. Now you notice PyMel is very little code, and that's where the strength is. That's what the push for PyMel is to be able to write less lines of code to achieve the same results. Now what PyMel is doing, because it wraps up the API and the commands module, we'll start with the time, we'll create the helix the same way, but we're using, now notice, the PM module. We're now using it through PyMel. So instead of getting back the string names, what we're going to get is objects. These are now objects. So what's cool about that is, now that you have this, you can actually just reference the vertex list with .vtx, and that looks very similar, if we go up here, to this, but we don't have to do it with strings. We have a function. And as far as I know, it seems that this might be using an iterator under the hood. It might be using, I haven't looked at the source for it, but I'm assuming that it would be setting up one of these for you and doing this functionality for you. So we're just going to say for v in the vertex list, and then you create a new vector. Now they've wrapped up mvector under their data types, so it's the PyMel core data types. You create a new vector, and we pass in the x value is a random number. And then we call translate by, and you can see these two lines are very similar to what's going on over here. We create a vector, and we use the translate by to pass the vector. Now you can see that up here I'm creating the vector first, and then I'm just updating it every time, so I only make one vector and I update it. That should be faster here. For some reason in PyMel it's slower if I create the vector right here and update it. So if I create the vector every time, somehow it's slightly faster. So we'll just go with that to give it the edge. And then again, a lot of the commands modules are right here at the top. So if this were just commands, it looks exactly the same. But we'll just make it PM. You pass it the object, it will delete it. We close off our time. And the last thing I have here is just a convenience test all. And what this is going to do is it's going to write what it's testing, and it's going to flush. It's doing it this way so that you see a printout after every test, so it doesn't wait until all the tests are complete to actually print. So we print, we run the command, and we get back the time, and we append that to our list. And we're going to run that 3 times for, and what I'm doing is I'm getting the results, and I'm also attaching a name, and I'll show you why I'm doing that. Once we get our results at the bottom, I'm going to sort the list so that the fastest time is at the front and the slowest is at the end. I'll pop off the fastest, and then I will just print the fastest and then print the rest of them and calculate their offset speeds. Alright, so now we understand the benchmark we're going for. Let's pop over to Maya, and again we've got our code path on the Python path. So if I import benchmark, right, I've got the benchmark. Let's actually, And you'll notice when you import the API and PyMel for the first time, there's a little bit of a delay while it loads everything up. So to do our test, what we have to do is do test all. Let me clear this. And you're not going to see anything here because it's going to create and delete it. And you're just going to see output right here. So I'm going to run this. And it's actually going to take a slight bit of time, and you'll see your pinwheel for a little bit because, again, remember it's going over 20,000 vertexes in the mesh, and you can see it's finished the commands. It's working on the PyMel right now, and that should finish up pretty soon and actually start the API, and then we'll get the results. And this will actually illustrate another point of mine about when to use each type of API, the commands, the mel. So here's the results. API is the fastest, 7.8 seconds. The commands comes in next at a little over 10 seconds, which is 1.29 times slower than PyAPI. And PyMel, 15.4 seconds, almost 2 times slower than the API. So this illustrates a point that where the benefit lies. If we look at our code again, here's where the benefit is. Writing less code and having it being more object-oriented, being able to create this helix and having this helix have its own functionality to check things about it, its width, and doing get attribute on it. But where it tends to slow down is when you have to do a lot of looping, crunching, heavy work. There's so much overhead in in creating these nodes. Every time it creates this vertex node, every time you get a vertex, it's creating a vertex type node, and there's so much overhead involved. So obviously when you have to do something extremely fast like that, the API is your best bet. And you can even intermix. Which is great is you can intermix the commands modules as I did, because there's no point in reinventing this. So the other thing I want to show you is I added this little part in here where we just set the subdivisions down real low so that we only have about 3,000 vertices. And I'm going to go ahead and reload this, and I want to show you the difference. I'll clear this up. Actually, I'll leave it up so you can see the difference. So let's run this again. This should go pretty fast. So as we're waiting here, hopefully I didn't even save it. Alright, well, I guess we're going to wait for a second. I'm allowed to make a couple mistakes in this video. So let's go ahead and save this and wait for our results here. And what I want to show you basically is that as you do even less loops, you can see that there's even a bigger gap in the performance of these tests. This should be done in just a second here. Okay. And you can see, again, this is showing you how consistent it is. You get the almost the same numbers. So if I reload this, and we can make sure that it picked up our change because it says py at the end, and I run this again, this should go very fast. Now you can see here a huge difference. This was only doing 3,000 loops, and Python was, or the commands module was 2 times slower, and PyMel was 5.5 times slower because of simply just the overhead, and just as well for the commands too, in creating, working with strings so much here. It's probably a lot of this working with strings. That's the overhead. And for PyMel, it's just creating those nodes is, devastating in terms of speed. So you have to make that choice in what you're going to code if you want to go with speed or if you want simplicity. And there's different reasons to go each way. So that being said, you can see why there's no reason for me to teach you PyMel, because if you go over the API and you learn this, which is still important, you should learn this anyway, because that's how you get the nodes into the core of the system. I mean, you have to have PyMel to use the PyMel features. So if you learn this, then PyMel is the same syntax just in a more Pythonic way. Alright, so we've got that done. Let's hide this here. And the last thing I want to do in this chapter is talk about how to set up your environment to start working with plugins. And you'll notice if we go into our code here, in this plugins directory, I've got our next example is a plugin, and I've also dropped some code into these subdirectories. And I'm just going to show you how to set up specifically for these, but you could do it for a facility location or your general projects location. So let's pull up a shell. And if you're on Windows, you can do it through the Explorer if you want, but I'm going to do it through a command line. And I'm going to go into, on a Mac, it's Library, Preferences, Autodesk Maya 2012. And we've got this here. And I'm going to go into my Maya Env. You can edit this in a text editor if you want. And what we want to do is a couple key flags, environment flags. First thing we want to do is set up the Maya plugin path. And this tells Maya where to look for plugins. And you can do multiple paths. What I'm going to do here is I'm going to move this up here, move this down. I'm going to say this is my plugins location. If you wanted more, you would just add more paths separated by a colon. I'm just going to do one for now. And the next thing I'm going to set up is the Maya script path. This is where it should look for Mel scripts. And again, you can put in multiple paths, but for our project, I'm going to put in Mel. And the last thing we want to set up is the Python path, and that's where Maya should look for your Python scripts, not plugins, but things that you would import, similar to the way you import the commands module, or it would find our asset importer if you want to set this up. So I'm going to set this up again right here. And what you want to do here is, so that you don't override completely the complete Python path, we should add in the Python path variable. So it's basically going to tack our location onto the front of the existing Python path, so all your other stuff will still be found. Now you can use this to set up your own location for all your code, but for our purposes, that's all we need to do. Alright, and so I'm going to hide that and hide this, and I'm going to restart Maya. Close this down here. Alright, so, and then open Maya again. Alright, pull up the script editor here, and now you'll see, if we go to Window, Settings, Plugin Manager, we now have, it has our new location, it sees the plugins that we have in there. I'm not going to work with them yet, but this is how you would load them in, like that. And if you don't get any errors, then you didn't screw up, and it came in. And for now, that's going to be the end of the chapter. In the next chapter, we're going to get into the API and take a look at how to write a node. So when we last looked at the asset importer, the last thing we did was we created a UI for it in the Maya UI code. But ever since 2011 Maya, when they rewrote the UI, the interface here in Qt, as you notice the interface is much different, they also let you write your own UI in Qt using a tool called Qt Designer. Now you have to download it, but this chapter is going to show you how to use Qt Designer so we can redesign our asset browser interface. So I'm going to pull up my browser, and let's see here. Okay, I've already got the site up. It's qt.nokia.com because Nokia owns Qt. And what you do is you go to the download section, and you can do this if you want to pause it and do it, or do this at a later time, but I'll show you how. And you want to go down to, you want the Qt libraries, but instead of getting the newest version, we should get a different version, and I'll tell you why. If we go down to the FTP archive at the bottom, it's kind of hard to find these versions, but I'll explain why I'm doing this. We want to get the same version that Maya is using. Because what that'll let us do is if we go to the source directory now, we're in Qt source. Let's pull this up, and I'm just going to find what I want is I want this 4.71. The reason I want this version is because that's what Maya 2012 shipped with, and in order to use later on, if you want to use PyQt, which lets you write UIs completely in Python, you'll have to build it a certain way, and I actually will go into that later in a bonus chapter, and I have a blog on how to do that. But if you get this version, you'll be sure to be set up for that step if you choose to actually go down the route of getting PyQt installed. So you would download this file, install the library, and what that gives you when it's done installing is a tool called Qt Designer. And you can find this installed after you're done. And when you launch it, it comes up with what you want to start making. In our case, what we want to start making is a dialog without buttons. So if I hit create, we get this blank slate. And I can resize this. And what we got on the left here is all the different widgets we can use, the properties for the selected widget, and up here is the hierarchy of what we're building. Now, when you build a UI in Qt Designer, there's some limitations because Maya is only going to recognize a certain amount of widgets to convert them over to the Maya objects that we looked at before, the things we could access, and the ones it can't understand you do not have access to in the code in the commands module. So let's build this a certain way, and I'm going to show you again why I'm choosing to do certain things as I do them. But let's go ahead and set our width of the dialog at 1000. Let's set this at, actually we'll make this smaller. We'll resize it later. Since I have limited desktop space, I'm going to stick to just not resizing it at the moment. What we should do first is we should set the name. Again, forgive my limited space. The object name, we want to set this to asset importer window. And what Maya will do is once it imports this, this will become the object name of the window as we had previously set it in code. This will be the object name of the window. Alright, and then we can go ahead and set title under window title. We'll call it asset importer. Okay, so now we want to start bringing in our widgets. And if you remember from the previous example, we had our grid library over here, and we had our imported list over here. So let's start laying out some stuff. Let's bring out some buttons. Okay, and let's call this one, this is the refresh library. Can make this a little bigger. Let's call this one, this was refresh the imported list of what's already in the scene. And then what we want is, you remember we needed to do a scroll over here and a list over here. So what we can do is we can find a scroll area. Let's set up a scroll area like this, and let's get a list. Now make sure when you get a list, there's two types. Make sure you, let's do the list widget. Okay? Set it like that. Now don't worry about positioning them too much. And so what we can do right off the bat is we can say, let's select these two, and we have these ways we can lay them out. Let's put them in a column view, like that. And let's put these in a column view. And we can actually make sure this doesn't get too wide. We'll go click on this, and there's a maximum size. We'll just call it 150. There you go. And we can do the same over here. It's currently at 138. We'll just say, let's just keep it at 138. So that when this resizes, there we go, like that. And then if we, with nothing selected, we can actually set another, let's see right here, make this a little wider. Doing our best to work with the space. We can right click on here, and we can say layout, and let's lay everything out in a grid. That's fine, a grid form will work for us, and it automatically pops everything into place. So now we've got the scroll imported. Now let's make sure we name this because we need access to some things here. Let's name this one first. This is the imported list. So let's call this imported list. Alright, so now we've got our list, we've got our scroll. Now you'll notice right now scroll has an automatic child, which is the contents. It's an invisible widget in here, and it's got a symbol on it because it currently has nothing in it and there's no layout. So what I'm going to do, and this is kind of a workaround, and I'll show you why in a bit. I'm going to just drop a button in here, and I'm just going to call it delete me. And I'm going to set this button to delete me. Now I'll explain this in a second, but now that we have this in here, we can just do a column layout. All I'm doing is clicking on this scroll, right click, layout. Let's lay out vertically. Okay, so it's in there. And let's go ahead and rename this a shorter name. Let's call it scroll. Okay, so we've got a scroll area with the main content for the scroll area has a child called delete me. And the reason, let's also make sure to rename our scroll area. Let's call that, let's see, let's call it library. Okay. Alright, do we have all our buttons named? Oh, we missed one. We got to call this one reload imported button. Okay, call it reload imported button. So now we look up here. Do we miss anyone? Oh, we got missed that one too. Let's call this reload lib button. All right. And okay, so now we've got everything laid out. And the reason that I put this, oops, not to save this yet. The reason I put this in here is because something I've found in the way that you use the UI. If you don't have anything in this empty UI, it's not going to export it and make it accessible to you. So I found that you have to actually have something in there because we want to fill this grid later on, but you know, we need something in there, so we're just going to delete this later in code. Okay, so now we've got this UI set up, and some things that it lets you do, though we're not going to really do it in this example, but I want to show you, is you can actually add Maya commands functions to the end of how it should create this button. So you remember that this has a -C, or you could say -command flag, and what you could do is you could actually click on this button and click on the plus, and we're going to add a string property. We're going to create a new property, and now the way you do it is, if you were doing this in Mel, you would say command, but for Python you put a plus in front of it and it tells it to do this in Python. So we say OK, and in here is where we could do you know, commands.sphere, or you know, any kind of call that you want to make. Now I don't want to do it this way because we want to hook these up later on, but you could add all the properties from the commands modules like this if you want to set up your widgets directly and not have to do anything later on. But we want this a little more dynamic, so I'm not going to do that. I'm actually going to delete that. And at this point, this is just an example. I have actually created this file for you, and it's actually located, let's pull this up here, under code, asset importer, Qt, and here is this file. This is for you to use, and this will be part of our example. So the structure that we have under here is we have our UI file and we have our asset importer win, which is exactly like this one, but we'll actually look at the difference of what we had to change in the win. So what we'll do is we'll pull up some code here. Alright, and let's go to our asset importer and go to, first we're going to open our original one. Let me close some things out. Okay, so let's look at our first one here. And if you remember, what we had to do is, you know, we imported our asset importer 3, and we created our asset importer, and we had this show function, and we had to actually make our window, make our layouts, make our buttons. And you remember, these are the same names that we just gave in that Qt designer: library, scroll, imported buttons. We gave all the same names so that everything stays the same, imported list, but we didn't have to do any of this. Let's look at this new version here.